Hello. Hello, my name's Timothy, and I am going to be going over trigonometry functions with transformations, okay? Now, a lot of people get mixed up with this, okay? So it is going to consist of you having a graph, and this is the question. Dun dun dun. Now, f of x is just telling us that we're doing a function. We're going to be plotting this onto a graph. Okay, so don't worry about it. Don't get confused. I will explain every last thing to you. First thing we're going to do is just easily look at our problem. We have f of x equals 3 sine parenthesis opening x minus pi over 3 plus 2. Now, as you can see, I wrote that inside different colors for a reason. I want things to be easy for you. So each of those colors represents something that's going to be plotted onto this graph. Each of these numbers and words. So we have the 3 sine. We have the parentheses x minus pi over 3. And then we have the plus 2. And don't be scared or alarmed. We are going to go through this together. Okay? Because math is complex. Now, as you see, I've written down amplitude equals 3. Amplitude equals 3. How did I get amplitude equals 3? Well, you know what? Let's go back and look. Can you spot out the 3? Yes, that is the 3 right here. So, why is our amplitude 3? Like, what is an amplitude is the question, right? Amplitude. Amplitude is like an absolute value that goes up and down, okay? So so let's say that our amplitude was 2, okay? 2 would go 2 spaces up our graph. So if we're looking at our graph, 1, 2, and 2 spaces down. But in this case, it's not 2, it's, what is that? 3. So how many spaces up and how many spaces down are we going to go? Correct, 3. So, as you see, I don't take that as a negative. I was just marking it so we know this is a negative. So we have positive 3 up and we have negative 3 down, okay? Because that is our amplitude. Ignore everything else. We will come back to that. Just notice we have 3 down and we have 3 up, okay? Let's move on, shall we? Well, now as you see, we have sine equals 2 pi. Sine equals 2 pi. Wait, where do you see sine at? Correct, right here. So sine equals 2 pi. Sine and cosine are both the same thing, okay? Cosine will also equal 2 pi, but tangent is different. That will only equal pi. It's half of a circle. It's not our complete circle, 2 pi. But since sine equals 2 pi, we're talking about a complete circle, okay? A complete circle. So, let's go back. Now, as you can see, we are talking about now the vertical phase shift. And as you can see, I have arrows pointing up and I have arrows pointing down. Because the vertical phase shift consists of the graph, our wave that you see. I don't expect you to understand it yet, okay? I really don't. I want you to look at it. So, our wave is going to either shift up as a whole or it's going to shift down as a whole. But how do you find your vertical shift, right? Like in this, where can you find your vertical phase shift at? Well, that's not that hard. It equals positive 2. Why? Why does it equal positive 2? It's very simple. As you can see, we have positive 2 at the end. This is our y. This is written out in a formula as y, okay? If we're doing, our vertical phase shifts, it's written out as y. So, we found what 3 means. What is it again? If you didn't get it, it's amplitude. If you did, congratulations. What about sine? What's sine mean? Yes, you are right. 2 pi. And if you didn't remember that, it's 2 pi, a full circle. So then, what's our y? Our vertical asymptote. I mean, not asymptote. Don't ever say that. Vertical phase shift. Yes, it's 2. So, as you can see, we just identified what plus 2 is. It's our vertical asymptote, and it's found at the end. Well, now, what does it do? What does that do? A vertical asymptote. Well, as you see, I wrote an arrow going up because it's positive 2. It's not negative 2. If it was negative 2, it would do a different thing. It would do the opposite of what I'm about to just tell you. Since it's positive 2, our original amplitude was 3, correct? Well, now we go up 2, 1, 2. So our entire graph just moved up 2. That is what happened. So, oh, hold on. If it moved up 2, what about the negative 3 down here? Well, actually, it goes up. So we have negative 2 here. So what can this one be? Correct. Negative 1. We have negative 1 right here. Sorry about this negative 2, by the way. Only if I can. Let's see. Okay. So, anyways, this should not be like that. It should be... Sorry, I only have a highlighter on me. It's negative 1. Bear with me. I'm sorry. But you will learn this, okay? We have negative 1. Well, now since we understand that, let's move on. We have a horizontal phase shift now to worry about. How do you get your horizontal phase shift? Well, let's look back. We know what 3 is. It's our amplitude. Sine is 2 pi. Plus 2 is our vertical phase shift. So now we're looking more about our parentheses. Our parentheses is going to tell us what our horizontal phase shift is. Now, let's look at this together. We have our parenthesis, x minus pi over 3, right? Well, we want to set it to 0. So now we have x minus pi over 3 equal to 0. And that's going to equal x equals pi over 3. Now you're like, how did you get that? You lost me. You lost me, right? Well, look at it this way. So we have the x minus pi over 3 equals 0, right? You plus pi over 3. And you don't want to discriminate, so you move it to the other side. You never want to discriminate a number, because a number doesn't want to be sad. So we move it over to the other side. Now, we have x equals pi over 3. Do you see how we got that now? This is our horizontal phase shift. You have to remember that. We will come back to it. Sine equals 2 pi. Remember that. That is very crucial. Okay? Sine equals 2 pi. So then, as you can see, we have 2 pi over 1 equals 2 pi. And you're like, how did you get over 1? Well, any number over, 1 is itself still. But there's a reason why there's a 1 there. And I'm going to go over that with you. Our period. Period is the time it spends for the graph to, let's say, hit here to here. This is one full period. Okay? And that's what this is going to help us find. So we have 2 pi over b. Okay? Now, where's our b at? Well, if you look at there's no b here, But if you look over here, our original equation for this, if you're not doing a phase shift at all, is a sine or cosine or tangent, but we're not focused on that. But sine or cosine. And it's bx. So b is before x. Let's look back over here. Can you see an x? Correct. So the b is right behind that x. And we don't see it though. But we know it equals 1. So that is the reason why 2 pi is over 1. And then if you simplify that, it's 2 pi, correct? So 2 pi b equals 2 pi over 1. That is what we did. Now, don't get scared. I know it's terrifying to look at, okay? Let's look at our graph. Well, as you can see, we have 1, 2, 3, 4. We have 1, 2, 3, 4. Okay, well, there's 4 on each side. Why? Because there are 4 points that complete the circle. Picture a piece of pie, right? You cut it into 4 quarters. You put all 4 quarters together. You still have your full pie. Ha! Pie. Pie. So, look at this. Well, we know our period is 2 over 1. But actually, it's not just 2 over 1. Am I right? Because what was it again? Yes, it was 2 pi over 1. There we go. Now it makes sense. So our period is 2 pi over 1. And we're multiplying it by 1 over 4 because our pi is split amongst 4, right? So when we multiply that, we're going to get 2 pi over 4. And now when you simplify that, it's going to equal pi over 2 because you divide the top and bottom, numerator and denominator, by 2. Okay? So now it's interesting. So as you can see, we have the pi over 2 that we just found, right? And now we just took our horizontal phase shift right here. And we're going to add them together. But to add them together, we can't just add them with our denominators looking like this. They have to be the same. And we can't just multiply one side because it's not going to equal. So we have to multiply both sides by the opposite numbers denominators. So as you can see, we have 3, and we're multiplying the pi over 2 by 3. We have the 2, and we're multiplying the pi over 3 by 2. Okay? What is that going to equal? Can anyone tell me this one? Well, it's going to equal 2 pi over 6, and it's going to equal 3 pi over 6. So now, when you equal that together, it's going to equal 5 pi over 6. And that is our first period. Second period, Second period that we're going to find. If you look here, our first one is pi And that's it, really, because it's not supposed to be anything else. It's just supposed to be pi. I messed up a lot on accident, but it's good because when you check over your work many times, you find things out. So it's pi, okay? But pi could always be pi over 1 anytime. And now we're going to look at another one. So we have 5 over 6. And what should that be? This is just to see if you could catch on. Pi. You know what? I don't like that one. I don't like that one for you guys. You guys deserve better. Oh no. You guys deserve even better. But better, I put it away somewhere. You know what? But you have 5 pi over 6. 5 pi over 6. And you want to add it with pi over 2. But how are you supposed to add that when the denominators are different again? Well, let's multiply both sides by the different denominators of each one. No, we don't need to do that. All we need to do is multiply the pi over 2 by 3. So we will end up getting pi over 6 plus 3 pi over 6. Well, when we add that together, we will get 8 pi over 6. And that's our third period. Third period is right here. So, as you can see, we just found those periods. And it wasn't even that hard, really. But here's the thing now. You're looking at this and you're just not understanding it still, Like, good thing we went over corrections, because those are corrections you're going to have to see when you're doing your work. But as you can see, there's going to be one more point, because there's only 1, 2, 3. And we divided by 4. So what's this last point that I'm covering up? Go ahead and try. Remember, you want to take the 8 pi over 6 and plus it by what? And when you're just doing this, pause the video, think about this. Now, did you get 11 pi over 6? And if you did, yeah, you're right. 11 pi over 6. Now you're looking at this graph, you're like, I don't understand, right? Well, here's the thing. Our normal typical graph, if we did not phase shift, would go up, down through the second one, because it's sine. Cosine will go through the first one, but no. Second one. Come back up, through, skip, through, and down. But what did we do? Can you remember? Yes, we did a vertical and horizontal phase shift. But our horizontal phase shift's right here. And we all remember that, right? It was pi over 3. That's what I originally put down. That's what's funny. Forgive me for that. I'm very sorry. Just doing a lot of math, thinking about this for you guys. Now, we look at this and we go, oh, okay. We're like, oh, we cover it up. Whenever we see it, we get scared. We show it. And we cover it up because we get scared again. And we show it. But all you have to do is really think this through. If we move up 2, okay, from 3, so 1, 2, right? This is where we are going to curve it back down, okay? But if we're moving it up 3, we got to go 1, 2, and now it's at -1, right? So if we're at 0, 0, and we move up 2, 1, 2, now we draw our graph. And what's our graph going to look like? It's going to go up like this, right? And then what's it going to do? It's going to drop down. And it's not going to hit this because we shifted it up by 2. But it's not going to hit past 1, remember? So we skip it over to the end. It goes a little bit past, and then it curves back down. Look at this now. We literally went up 2, drew our line, right? Then we go down a little bit past. We don't cross here. We go down. We go under because we don't want to cross this -1. We go up and curve down. That is how you find it. And the same rule applies if you're going backwards. Up. That's how you do it. Yes, I understand maybe this wasn't the best, illustration scene, but at the same time, I tried my best, okay? I recently learned this, and I feel like I did give a good brief understanding about what it is. And I just want to test you because it's not about the illustration, unless you're being tested, ha. But, you see what I'm talking about. But I think what's more important is what lies in the formula. So I'm going to point at each one and see if you can restate what each one is. Asymptote. What does sine equal? Oh, you caught me. You caught me. I tried to trick you guys. I tried to just move on. Look at that. Whoever failed for that, you're wrong. Because what's that called? Amplitude. So now what's sine equal to? Yup. You got it. 4 pi. Ha! Got you again. It's 2 pi. But whoever got it right, congratulations. What's this for? You're right. Our vertical phase shift. So, I got you again. What's this really for? And if you did say horizontal phase shift, you are correct. So what can this stand for? Vertical phase shift? And yes, if you agreed, yes, it is vertical phase shift. So, thank you for watching, and please enjoy.